And the testing set were already divided in the appropriate ratio. And next, after this, build the value, and our model should be fit the model, and testing means here we are performing the validation. After this validation, we can get the performance in terms of accuracy. So here we can find the our metrics also. In terms of metrics means accuracy, precision. Here we'll get the performance of the system. So these are the examples. Before going to the examples for the regression analysis, so let me explain the what is meant by linear regression and what is meant by logistic regression. Why we go for the logistic regression? As our second day session for this FDP is the logistic regression, so we cannot directly move into the logistic regression. So that's why we'll see some examples for the machine learning before going to the regression analysis. So applications of machine learning. So this is the first application. Suppose if you got message like this in our mail from so and so mail ID and to and a deal of the week buy now, like this message you got means, so if you consider this as a spam mail or inbox mail, so think and tell me. So the second message is from so and so person and to and the subject Christmas dates and hey and so this is the message, correct message. So this is the non-spam message and this is the spam message. So using the machine learning algorithms, we can separate the spam and non-spam mails also. So this is the applications. And the next applications of machine learning, this figure shows the we want object detection to detect the dog or and that person. So based on some suitable algorithms, we can find the object detection also. So carefully observe the figure. So the person picture and the dog picture two are there. So we can identify the objects using some suitable algorithms. So this is nothing but the applications of machine learning. And next, we are moving into the next application. So this we can treat it as a classification application. See the classification application. So here our function is before model any system, we need to write some problem definition. So here our function is female or male. We need to classify two classes, female class and the male class. So here we can write our decision boundary like this. So all are men's and below this decision boundary we have the female pictures. Okay, na? So this is the decision boundary. Best decision boundary line is like this. Classification example. And see our problem definition here. F of x equal to loan dollars, yes or no. If any person required the loan, so then you will say yes, otherwise no. So here also we need to develop our decision boundary. Decision boundary is like this. See the picture. Yes person, the person who say yes. So these are separated into the boundary lines. So these are the yes persons and these are the no persons. So this is the possible decision boundary. According to our picture, this is the possible decision boundary. So this is the classification example. Next, similarly, one more problem definition is age problems. So age problems, here different various age persons are there. So 20 years old, 31 years, 40, like that different age persons are there. So this is the problem of a regression example. Why? Because some numerical values are there. Input at the same time outputs are the numerical values. Then this problem comes under the regression example. Next, drug discovery. Using the machine learning algorithms, we can discover the which one is a good medicine, drugs. Okay, na? So depending upon the labels also, we need to apply the training process. After that, we can discover the drugs also. Next, medical diagnosis. medical diagnosis. So this is the original picture and MRI scanning and the CT scanning. So based on these images, okay, na, apply suitable machine learning algorithms, we can find the different diseases also. Early, we can predict early. Next, iris verification. In security applications, we can use the iris verifications and handwritten digits. Handwritten digits. This is also very important application. Next, radar imaging and speech recognition. This is a very important application. Nowadays, everyone are using this speech recognition. And fingerprint image. Signature verification also very important. And face recognition. So out of the data sets, we can recognize one person. And the total number of images were divided into training set, at the same time testing set. So that we can recognize the face by using the validation testing, target recognition and robotics vision, traffic monitoring. So these are the real-time applications. Traffic monitoring also real-time applications comes under. So next, I will explain the difference between the classification and the regression. Classification. So as I explained earlier, spam and the inbox mails. So we can give the training data to the system. The system predict the output of the system. System can predict the output. So based on the training data, the system can predict the output. So inboxes and spam folder, it will classify. Okay, so two classes here. So the computer program is asked to specify which of K categories an input belongs to, so that it can categorize as inbox and spam folder. Next, regression. So regression, the same student profile we can explain for classification, at the same time regression also. So in classification, we want whether the student is pass or fail only. Whereas in the regression, we want the percentage of that student also. So for that, this is the regression example and this is the classification example. Classification, pass or fail. Or here we can predict the student marks also, percentage. Next, regression analysis in the machine learning. Before moving to the logistic regression, so what is the terminology we are using the regression analysis? What is the use of regression analysis? We'll see that one. So regression analysis is a statistical method to model the relationship between a dependent and the independent variables. So what is meant by dependent means target parameter, target value, and independent variables means predictor. Suppose where BMI, we need to measure some BMI means, okay. So in that, what is the independent variable and the dependent variable? So like that, with one or more independent variables. So regression analysis helps us to understand how the value of the dependent variable is changing. How the value of the dependent variable is changing. It means the output value or the dependent value or the target variable is changing. Is a real value, numerical value or the continuous value corresponding to the independent variable. So it predicts the continuous or real values such as temperature, age, salary. Temperature. So what is the room temperature? And the age. Suppose in the data set, some person names and the ages are given, and so that we can build the model, and some particular age. After that, for testing case, we can give some particular age. So we can measure the suppose height or weight we can also measure, so that we can calculate the age, salary and the price also. And depending upon the experience, we can predict the salary. Depending upon the house size, and we can predict what is the rent of that house or the price of that house also we can measure. So these all are the real time examples. So this is the example. See this one. there is a marketing company A who does various advertisement every year and gets sales on that. So this is the one company, $90 or $90 spends for the advertisement, okay, na, so that they can get the sales. How many sales they get? $1,000. Similarly, they spent $120 means they got the $1,300. So depending upon the advertisement, so the sales also increasing. So here $100, $1,200, $130 means 1,380. So they are spending huge money on the advertisement means they're getting the sales also increasing day by day. So after that this data set, we can predict the output of $200 means what is the sales of in that year. Suppose if you consider the 2019 or 2020 year, they spend $200 means how many sales they will increase. What is the sales count? So that we can find this value using the regression analysis. So what are the terminology? So a dependent variable. In the definition, I have said dependent variable, independent variable, outliers, underfitting, and overfitting. So this knowledge is required to analyze the system. So dependent variable. So dependent variable is nothing but the target variable. Independent variable means predictor. So the factors which affect the dependent variables or which are used to predict the values of the dependent variables are called independent variable. So predictor. So in the machine learning terminology, we can say target variable and the predicted variable are actual value and the predicted value, actual value and the predicted value. So outlier. So this is a new word, outliers. So outlier is an observation which contains either very low value or very high value. So in comparison to other observed values, that means in the training data, some value is very low value and some value is a high value. So because of these values, we cannot fit our best fit line. We cannot draw the best fit line. So those are called as the outliers. So an outlier may hamper the result. So it should be avoided. So try to avoid the outliers. So this is the outliers. And the next one is underfitting and overfitting. So this is regarding the training data set and the testing data set. So if our algorithm works well with the training data set, but not well with the test data set, so such problem is called as the overfitting. So overfitting is related to our training data set. So our system works well with the training data set, so that is called as the overfitting. And whereas the underfitting means our algorithm does not perform well even with the training data set, then such problem is called underfitting. Okay, so in terms of our data set is large data set. Suppose if you consider the large data set, so the training works well, so that is a overfitting. Otherwise, the algorithm does not perform well with the training data set means this is the underfitting. So this is the terminology is required before moving to the logistic regression. Dependent variable, independent variable, outliers, and the underfitting and the overfitting. So why do we use regression analysis? So regression analysis helps in the prediction of a continuous variable or a numerical variable, numerical output value. So these are various scenarios in the real world where we need some future predictions. Future predictions means weather conditions, sales prediction, and marketing trends. These are the real-time examples. Regression estimates the relation between the target and the independent variable, and it is used to find the trends in the data. So mainly, it helps to predict this point is important, it helps to predict the real or continuous values. Helps the real and continuous values. So what are the types of regressions? Linear regression, logistic regression, polynomial regression, support vector regression, decision tree, random forest regression, and ridge regression, and the lasso regression. So in our FDP schedule, so linear regression, logistic regression, and after that support vector regression and decision tree also sir will explain the tomorrow or day after tomorrow, and random forest also sir will explain. So next, linear regression. See the diagram. So on x-axis means this is the independent variable experience. Experience, we are considering the experience of the employee 2, 4, 6, 8 and 10. So this is the experience x value. So on y-axis we are considering the dependent value, dependent variable salary considered. So like 40,000, 60,000, 80,000 like that. So for 2 years of experience, what is our salary? So if you draw the line on this linearly separable line, so 40,000. Next, 4. If you draw the line on this diagonal line, 4 means this is the 60,000 like that. So these are the so based on these data points, data set values, we can draw our line. So this is the decision boundary or the linear line, linear regression line. Okay, linear regression line. So linear regression line. So this is out of all these points, data points. So this is the best fit line. If you consider all these data points, this is the best fit line. Next, similarly, logistic regression. Logistic regression is another supervised learning algorithm and also used for the classification problem statements. So we have dependent variables in a binary or a discrete formats such as 0 or 1. So many categories also. Decision making statements also here we are considering categorized variables. So such as 0 or 1, yes or no, true or false, spam or not spam, examples. So it is a predictive analysis algorithm which works on the concept of a probability. So that's why here we are considering the sigmoid function. In logistic regression, we are using the sigmoid function. So which is a complex cost function. This sigmoid function is used to model the data in logistic regression. So before moving to the logistic regression, why we go for the logistic regression, I will explain this one. So suppose if you consider our data set like this, on x-axis we are considering our weights. So on y-axis we are considering obesity values, means obese. So this is the 0 value and this is the 1 maximum value. So suppose a data set values like this. So we want to fix one weight value. So suppose a greater than 60 or greater than 75, some value here we are considering. So this is the point I am considering greater than 75. So my weight is greater than 75. So what is the value? What is the value? Predicted value. So obesity predicted value, suppose. So these are all are my data points. So try to draw the convenient fit line. So this is my fit line. Suppose if we consider this fit line linearly consider this line linearly separable points. So suppose this is the 75 means if we draw like this line on this dependent variable means, so this value is suppose 0.5. This is 0. And after that the weight is less than 75. Suppose here consider 60. 60 means the obese value is something 0.3. So if increase my weight, suppose 90, consider weight of any person, suppose this is 90, means this value is greater than this 0.5. 0.5 means suppose 0.7. 0.7. So like this, some more points are also added in my data set. Something outliers are there. These are the outliers. Means outliers. So the distance between these 2 points are very great. very large value. So distance between 2 points. So these are the very high values. Similarly, if you consider a 30, consider 40 value, means we can find the value like this, but our decision boundary is here, means this is a negative value. This is the negative value. And this is a, suppose if you increase the data training data set values, means it is greater than 1. Here if you draw a line like this, means this value is greater than 1, or base value is greater than 1. And if you consider below this line, suppose, so these values are negative values, means less than 0 values, means again we need to draw one more best fit line. Suppose this is the best fit line, and after that we can draw like this best fit line. So the best fit lines are not constant in the linear regression. So this is the linearly separable line. So what is the expression for linear line? So this is the line is y is equal to mx plus c. Y is equal to mx plus c. So straight line. So this is the straight line, y is equal to mx plus c, where m is the slope and c is the intercept, and this x is my data points. X is my data points and y is output value, or predicted value, and a target value. So this is our basic expression. So we need to set different best fit lines. So because of these reasons, we are considering the sigmoid function. Suppose we can draw the sigmoid function like this. So 0 to 1. 0 to 1. So because of the two conditions, so suppose here y is equal to mx plus c, otherwise y is equals to beta naught plus b1 into x. So this is also linear expression, and otherwise y is equal to w transpose x plus b. So bias values. So this expression we can find the weight. Need to update the weights also. So suppose any line passing through this origin, means this b values and beta naught values and c values are zeros. So directly we can find the y is equal to w transpose into x. Based on the input set, we need to provide the training so that we can update our weights. So because of these region best fit lines, we are considering the sigmoid. So sigmoid function is y is equal to f of x. So this value equal to 1 by 1 plus e power minus x or z. So whatever value we are considering as a independent variable, so 1 plus e power minus z value. So I'll show the graph sigmoid. So this is the sigmoid graph. Suppose this x value equal to 0. Suppose this x value equal to 0. So what is the value here? 1 by 1 plus e power 0. So 1 by 2 means this is the 0.5 value. Suppose x value equal to infinity. X value equal to infinity means e power minus infinity 0. So 1. So it reaches the maximum value. And x value equal to minus infinity means it is a 0. So this is the sigmoid function. So that's why logistic regression method is more popular. So next one. And moving to the logistic regression, this is the example. By seeing this example, we can make our decision also whether we need to carry umbrella or not. So this is the decision making process also. Logistic regression is like the decision making process, but it is used in situations where the outcome is either yes or no, true or false, or 1 or 0. So the outcome, what is the outcome of this one? Real-time example. What is the outcome? So binary outcome is bring an umbrella, yes or no. So bring an umbrella, yes or no. So this is the outcome of this one. Depending upon the situation, we need to make our decision. Next example is based on the student education. So SAT score. So the first column we are considering the SAT scores, and the second column we are considering the GPA scores and whether that student is admitted in the college or not. So based on the SAT score and the GPA, so we need to decide so whether no chance of being admitted or chance of and definitely be admitted. Definitely be admitted means when the outcome value is equal to 1. So 0 means no chance. So this is the classification 0 or 1. But we are using the logistic regression means if a student has a score of 0.75 and in between some values we are considering 0.75, it means there is a 75% of chance they will be admitted 0.75. So this is the example for SAT score and the GPA score. Logistic regression, we are using this one. How this logistic regression will work? So this is the process. Input SAT scores and GPA go into the logistic regression model. So the model calculates the score based on the inputs and the current weights. So the y value equal to w1x1 plus w2x2 plus b values. So we need to assume initial weights. Based on the input data sets x values. We calculate the score also. And this score is converted to the probability using the sigmoid function. So less than 0.5 value and greater than 0.5 value. So we can convert it into probabilities. Based on how accurate this prediction is compared is known outcomes. So admitted or not admitted. So model using gradient descent. For this, in this model, we are using the gradient descent algorithm to calculate the error value. After calculating, we need to update the weights so that we can predict the good results. So improve the predictions for the next round. So this is the working process for the logistic regression. So classifier function scores x1 value and x1 is the SAT scores and x2 is the GPA. And we need to find the optimal weights. How to find the optimal weights? So here is the expression z is equals to x1 w1 plus x2 w2 plus b values. So we need to find the optimal weights. So here is the some mathematics intuition and the geometric intuition will involved in this one. Some process we need to update the weights and after updation again calculate the error value, the predicted value minus actual value. So we will get the error. So if error is reduced, then stop updating the weights. So this is the process. And the relationship between the sigmoid function and linear classifier. So 0, 2.5, 5, 7.5 and 10. So at 10, the maximum value is 1. So sigmoid function means 0 to 1. The predicted values in between 0 to 1. And this is loss function. How to calculate the loss function? So the loss function measures the difference between the model's predicted probabilities and the actual probabilities. So actual probability, that means loss equal to y hat minus y into again the x values. So y hat is the predicted value and y is the actual value, so input values. So after finding this loss value, again we need to update our weights. So new weights equal to old weights plus our data set input values. Again we need to add these two values. So here the binary cross entropy is the loss function used in the logistic regression. So what is the entropy formula? We will see this one. Loss equal to 1 by n. So 1 by n is nothing but here we are calculating the average value. Average value yi log of y hat plus 1 minus yi log of 1 minus y. So this is the entropy formula. Binary entropy formula, only two values, yi and 1 minus yi. So what is the n value? N is the number of data points or samples and yi is the actual outcome. So this yi is the actual outcome and y hat is the predicted value. So the output of the sigmoid function lies between the 0 and 1 loss function. And similarly, gradient descent. So how to use this gradient descent in logistic regression? Suppose on x-axis means this is the independent variable.
ట్రాన్సాక్షన్స్
Weight.
కార్డు కొత్తగా వచ్చిందా? కార్డు ఇవ్వకుండా ఏం కాదు. కార్డు ఇవ్వకుండా అది కాదు. అయితే కార్డు ఇవ్వకుండా నువ్వేం చేయదు. నెంబర్ కావాలి కంపల్సరీ. నువ్వు కంపల్సరీ నువ్వు ఆ కార్డు నెంబర్ ఉంటేనే ఏం చేయగలుగుతావు. నెంబర్ లేకుండా ఏం చేయదు.
అడగలే అసలు వచ్చిందా రాలేదని వాళ్ళని అడగలే, వాళ్ళు అసలు కనపడకుండా దాచి.
ఇప్పుడు
Yes, gradient descent. So the cost function, how to reduce the cost function? Our cost function should be minimum. So starting with negative direction, so this is the positive direction. So, and this is the negative direction. Starting with the negative direction, we need to find our gradient value, particular point. So gradient is nothing but a differentiation, so that only we can draw the slope. So this is the tangent. We can call it as a slope also. So after this point, it will continue. Next point, similarly, find the gradient value, and again we need to update our weights, and next move on to this place. So this is the minimum cost value. Why? Because here the slope value equal to 0. Here the slope value equal to 0. And the derivative of the cost. So if we move on to this one, maximum cost, and here this is the minimum cost. So if it starts at the negative side, we will get the minimum cost value. So cost, here this point we can reduce our cost value. So what is the process of gradient descent? We'll see this one using the chain rule. So here we are applying the partial differentiation with respect to the weights, dou wj, dou L by dou wj. So this is the partial differentiation. So we can split this partial differentiation with respect to the predicted values also. Dou L by dou y hat divided by dou j. Okay, so that we can adjust like this. So dou L by dou wj. So this factor we can write like this also. So after performing this, we can get the y hat minus yi into xij and update our weights. So this rule we can call it as a update rule or weight updation rule. So wj minus eta dou L by dou wg. So this eta value is a learning rate. So mainly this eta value is in between 0 to 1. Sometimes it may be eta equal to 0.5 or 0.2 like that. So this is the learning rate. So here we are using the chain rule mainly, and the delta learning rule also. So to find our cost function, and weight updation rules also, and scoring function. So after updating these weights, we can find the scores values, and z is equal to w1x1 plus w2x2 plus b, so that we can find the best fit lines. Data points corresponding to the sigmoid function. So we'll see here. Suppose if we consider different decision boundaries, suppose. So here the value is z is equals to 1.5. Next, z is equals to 0, 0, z is equals to minus 1.5. Like that the values are there. So if we combine this decision boundaries, positive values and the negative values, so here 1.5 means it reaches to the 0.8 probability. This is the 0.8 probability. And similarly, minus 1.5 also 0.8 only. And next, 0.75 minus 0.5 and 0.5. The value is 0.5. So that the loss function over iterations, we can find the loss function like this. So data points with decision boundaries. So this one regarding the logistic regression. So before explaining the logistic regression, I explained the linear regression. Why you go for the logistic regression? What are the drawbacks of linear regression? And logistic regression is best suit for the output value is a continuous or the numerical values. And also some examples also we consider, and the real time examples also. And next we'll see the Python program of this logistic regression. So this is the logistic regression considering the data set MNIST data set. So this is the large data set modified National Institute of Scientific and the Technology. So this is the data set. Generally this data set is useful for the image processing applications. Image processing applications, this suppose this is the digits data set, MNIT data set. See the size of this MNIT data set. So this is the large data set. So before executing this program, so here we need to import some library files. So like import is nothing but like in C language hash include. Okay, header files we are including header files. Here also we are import matplotlib.pyplot as a PLT. So matplotlib, so this is the library file which is used for the visualization. So we can say all the plots of this one, and the NumPy for the numerical applications, and the pandas for the metrics. So for the confusion matrix we can get the metrics also. So here we are importing the pandas, and the C1 library file also for the visualization, and sklearn for the machine learning, all the machine learning applications, algorithms, and input data sets. So here we are importing our data sets and the train set and k-fold algorithm also. Yesterday I explained the k-fold algorithm, and it depends upon the k value, and sklearn pre-processing, import normalizer. So all are we writing. So collections import counter. So this is the collections import counter. So like this is a container. It collects all the elements. And after that MNST dataset, we are using MNST dataset, and iris. So use this one, NumPy concatenate function. So target values and the feature names. After that, all the pixel values, how many rows here we are considering, see this one, 5 rows into 65 columns, and the target values. What is the shape of input data? So here our print statement is shape of input data. So input data is 1797, 64. So similarly, shape of the input image is 1797 and 8, 8, 1. So this is the size of the, suppose number of samples 1797, and this 8 by 8 is size of the matrix, and 1 is the number of channels here we are using, reshaped. So shape of the input image. So if you run this program, we'll get the training score is 1 and the testing score is 0.96. So that means 96% of the accuracy for the test case. So test score is 0.96. We obtained this one. So this is the example for the logistic regression considering the MNST data set. And one more example also we can consider. Suppose we can predict the tumor, whether that patient's having the cancer or not. So for that we can predict. So this is the program, sklearn import linear underscore model. So this is the data set samples. These are the samples we are considering 3.78, 2.44 like that, and the reshape -1, 1. So we can adjust the number of rows in one column. So the meaning is, so numpy dot array. So suppose 0 or 1. So if the patient having cancer means 1. So no cancer means 0. This is the value we can predict. So predicted value. Suppose if you run this program, is 0. So why? Because here the predicted equal to log dot predict numpy dot array of 3.46. So 3.46 value at the tumor size equal to 3.46, the predict the output value. So here 3.46 value. So consider our data set value. So the output predicted value equal to 0. So that means the patient not having any cancer tumor. So based on this size, we can predict this one. And also one more example is import numpy from sklearn import linear model. So here we are adding the one important command. So that is log underscore odds equal to log odd dot coefficient, suppose COEF underscore. So because of this statement, the size of this, suppose here we are considering 3.46. So here the size is enlarged to the 1 mm extra. That means 4.46. 4.46. So it will add 1 mm extra. So if you execute this program means the answer is 4.03. So the same data set we are considering, the command is different. Log underscore odds equal to log odd dot coefficient. So the output value equal to 4.03. So these are the few examples for the logistic regression of Python. So you can directly run program using the Google Colab also, but I executed in the Jupyter notebook. So Google Colab also you can run the programs. So we'll share this program also, logistic regression, the main program. You can execute in our Google Colab already. Otherwise, you have the tool, Python tool means we can run the tool, Jupyter or Spider. So this is the program. So this is about the logistic regression. Thank you everyone for listening this session. So dear participants, we can share the yesterday's slides and today's slides also in the WhatsApp group, and logistic regression program also I will share in the group. Okay, thank you all.